Yes, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In my discussion today, I'm going to look at the third category of the concept of asymptotes. And in our last discussion, I had basically defined this concept of an asymptote as a line or a curve that however close it may come, it's not going to touch. Now, in previous discussion, we had basically given an example of a vertical asymptote using this particular representation for the concept of x and y axis. And of course, I said that we can use this specific representation for representing the various types of asymptotes that we're going to come across, which can be given in this specific case for the vertical asymptote. And we said that this can be defined on this particular line that we're going to give us x is equivalent to 0. And we said that for a vertical asymptote, this can be defined on a function given in terms of x, fx over gx, whereby we said that this value for g of x is going to be given as a 0. And we had given an example of this specific function, and we said that we are going to have this specific function for the value of this gx equivalent to 0. And of course, that's going to be forming our specific asymptote in this particular case. So if we try to look at this specific aspect of a vertical and horizontal asymptote, which we had given in our previous video. Now, I said that basically we can as well give the horizontal asymptote using this specific illustration for the value of perhaps 3, which we had just found from our previous evaluation. So kindly you can check our description box for a link of those two specific videos for vertical and horizontal asymptotes, which are going to be giving us this specific case. And we have defined this specific, of course, asymptote for the value of this particular equation. Similarly, for this specific function, which is going to be defined on this, of course, horizontal asymptotes are going to be defined on this function, whereby we're going to see that the value of x is going to be tending to either positive or a negative infinity. And in this case, we had said that therefore we're going to have these asymptotes given in the, of course, a value of this specific 3 plus epsilon, whereby we say that epsilon is going to be a derivation of a positive infinity, whereby we're going to have another representation for the asymptote given in terms of 3 minus, of course, epsilon, whereby the two values for positive and negative are going to be representing either positive or negative infinity given as such. So kindly check those specific links. They're going to be assisting us in trying to contrast these 3 different types of course, asymptotes, which I've just mentioned. So in this case, for the Skew asymptote, we're going to see that it's going to be having a different format of trying to represent it, whereby we're going to consider a function if it is defined as, of course, fx all over gx. This is going to be given in terms of a range of constants, which you are going to see. Now, this is going to be represented as a polynomial that is going to be given as a range of constants, which you are going to see for ax, b plus c. Now, in this particular case, we are going to have this specific polynomials, which are going to be, of course, of at least of a first degree given as such. So we're going to have f of x and y of x. So this is going to be g of x at least of degree 1. So they are going to be at least these two functions, which are polynomials, are going to be at least of 1 degree or first degree, and then we're going to have a not equivalent to 0, b not equivalent to 0, and c not equivalent to 0, where a, b, and c are constants. So in this case, we're going to see that we can define this specific Skew asymptote using this particular function, whereby we have said that this function can be defined as such, whereby fx, which are going to be polynomials, are at least of 1 degree, and this specific range of values for a, b, and c are going to constitute constants which are not equivalent to 0. Then we can define a Skew asymptote, which is given in terms of y is equivalent to these particular values of a, x plus b, which is going to be forming our Skew asymptote defined considering these specific conditions which we have given up as the statement. Now we can consider a specific case of course, a graph or a function which we try to see whether it's going to be forming our, of course, a Skew asymptote, and try to see how we can define that specific Skew asymptote from this basic evaluation. So in this case, we're going to consider a function of the form y is equivalent to the square of x plus 2x, and this is going to be divided by x plus 3. So in our previous discussion, I had said that if we are going to see that this is going to be of a higher degree compared to the denominator, then therefore we're going to, this is going to be an improper fraction, and we're going to write it in its, of course, quotient and proper form. And this is going to be giving us the value of x minus 1 plus 3 all over x plus 3. So if we try to do an evaluation of this one, it's going to be giving us this two specific function. So this has an implication that therefore that our asymptote is going to be defined by this particular value of y is equivalent to x minus 1. And if we try to look at this one from our specific function, we're going to have this one. If we can sketch this one, we're going to have this one in terms of perhaps a curve, whereby we're going to see that if we have the values of y and x given in terms, so if the value of y is equivalent to 0, then x is equivalent to 1, and if x is equivalent to 0, then y is equivalent to -1. So we can have these two coordinates for the lines which we can represent in terms of course, our asymptote, which can be given in terms of, so let's have this one given in terms of 1, 2, 3, -1, -2, 1, 2, 3. So if we try to see, this one is ranging between 0 and -1 for the two values, and therefore we're going to consider the first coordinate for x, y. If x is equivalent to 1, then we're going to have 0 as one of the coordinates of this specific. So we're going to have x, y given in terms of two sets for 1 and 0. And then the second set is going to be giving us, of course, this 0 and -1. So this is going to be 0 and -1. And therefore, we're going to have our specific line for this asymptote given in terms of this particular line that's going to pass through these two specific points. And it's going to be the line of y is equivalent to x minus 1 given as that. And that's going to be forming our asymptote. And therefore, we're going to expect these specific values, or rather the specific gaps, to be approaching that specific lines using that demarcation using shown as such, and this is going to be forming our particular asymptote whose curves, however close they come, they're not going to be touching. And this is going to be referred to as a Skew asymptote, which is going to assist us contrast it with the previous discussion that we have had on horizontal and vertical asymptotes, of course, as I just mentioned. So kindly check our description boxes for various links of other videos. Engage us in the comment section, or also subscribe and also ring that notification bell for an update on various discussion in math and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.